So, welcome for lecture 8, so key indicators of sustainable agriculture. So, last lecture we have discussed about what is sustainable agriculture. So, this lecture will be focusing what are the key indicators of sustainable agriculture and how we can evaluate the sustainability based on the key indicators. So, coming to this one key indicators, what are the key indicators? You see, so this is the as a man's health is judged by his physical and mental attributes. Similarly, the well-being of the ecosystem is primarily estimated by some parameters. These parameters are called key indicators. Knowing the indicators, what happens once you know the indicators, then this enables the policymakers, farmers, business and civil society to better understand the current conditions, identify trends, set targets, monitor progress and compare performances among regions and countries. What to say? So, the key indicators of sustainable agriculture, once we know we want to achieve sustainability, we must know what are the indicators of sustainability. And if you know the indicators, then you look forward how to achieve the sustainability knowing the indicators. That means, we have to know the indicators and we have to work accordingly how we can achieve and how we can increase the efficiency of our production systems, so that this sustainability is maintained. So, coming to the indicators, these are the 5 main indicators for agricultural sustainability. So, water, soil health, land conversion, pollution and climate change. So, if you look at the 5 indicators, once you know the indicators and their use, their importance in agricultural production systems, so we should know how to protect them, how to protect water, how to economize the use of water and how to maintain and improve the soil health, and land conversion, how to minimize land conversions, that means the deforestations, how to check the deforestations, and the pollutions means the agricultural activity, that is say fertilizers and pesticides, how we can increase the efficiency of inputs, so that the fertilizer or the application methods, so that the pollutions due to the input management, either fertilizers and pesticide, should be kept as minimum as possible or no. Then finally, climate change, as you discussing just last previous class. So, how the agricultural activity doing the management practices, they can minimize the climate, the anthropogenic activity, as you say, that can minimize the climate change, means minimize the greenhouse gas emission to the atmosphere. So, we will discuss the indicator one by one. So, let us come to the water. If you see the water, the agriculture accounts for 70% of world's freshwater withdrawal and for 80 to 90% of its freshwater consumptions. Moreover, the water availability in future climate is going to be limited. So, we should be very careful in using water, and we should think of the technologies how we can improve the production of the crops with less and less water. Then, if you see soil health, second indicators, soil plays a key role in maintaining a balanced ecosystems and producing quality agricultural products. However, soil erosion and degradations continue to threaten the availability and productivity of land. So, the soil which plays a key roles and the soil productivity, to maintain the soil productivities. So, our activity like the minimum tillage or conservation tillage or the soil conservation practices should be focused how to minimize the soil erosions or the soil degradations. Also, soil is being lost around 10 to 40 times faster than it is being replenished. so which pose a threat to long term human food security. So, in that case, so in many places soil's capacity to retain nutrients, retain moistures and maintain a healthy pH is also declining. So, that is the question. So, how to maintain the soil health long term as an indicator. So, next one is a land conversion. Since the dawn of the first agricultural revolutions 8,000 to 10,000 years ago, growing crops and raising livestock have been the primary cause of loss and degradation of natural ecosystems. That means, today around 37% of the planet's land mass is dedicated to growing food, of which 12% is for the croplands and rest 25% are the grazing lands. The majority of current land use change in the world is forest, wetland, grassland are being converted into farms and grazing pastures. So, in that way the land conversion or the deforestations, that is also contributes to climate change. How can check the deforestation, maintain the natural ecosystems. And the fourth one, the pollution, the nutrient pollutions and the pesticides pollutions. Nutrients means maintaining the balanced soil nutrient levels is critical to both production and the environmental health. If there is a deficiency of nutrients can reduce the soil fertility and limit productions, while excess nutrients can lead to ecosystem degradations and if they are lost either to water and air. So, that causes the pollutions, air pollutions and water pollutions, eutrophications also. And impacts of excess nutrients on the environment include the eutrophications of surface water, impairment of groundwater and emission of harmful greenhouse gases, particularly nitrous oxide as we discussed. So, the nutrient management is very important and scientific and efficient nutrient management is very important for sustainable agricultural productions. If there is less inputs, less input application, less nutrient, that reduces the crop yield, which you do not want, which we do not want to sacrifice the yield of the crop. And if you are applying excess, so the surplus the nutrients either they are lost to the either leaching loss goes to groundwater contaminations or they go to rivers and they make eutrophication of the surface waters or they may release to atmospheres as a greenhouse gas as a nitrous oxides and cause as a contribute to the global warming. So, nutrient management that should be very scientific and very efficient way to minimize the pollution levels. And next is pesticides. If we are discussing also a lot about pesticides because of the insect chemical pesticides, while beneficial may be for the protecting the crops from the insect pest or the diseases, but can have the detrimental effects on human health. That is how wildlife or the water quality due to the pesticide contamination. So, that is the environmental impacts toxicity of the constituent chemicals. So, the pollutions that is either the nutrients or the pesticide pollutions that should be kept in mind while attaining the sustainable agricultural productions. So, last one indicator that is the climate change. If you see the climate change, say the agricultural activity that contributes to greenhouse gas emissions, about 13% of global anthropogenic greenhouse gas emission came from agricultural productions, and they are from ruminants or the livestock, manures, fertilizer, rice and energy use. And land use changes mostly which triggered by agriculture contributes to because conversion of the deforestation forest lands to agricultural land. So, that contribute to another 11% of global greenhouse gas emission. And if you give example of the right hand sides, how the nutrient management practices that can cause greenhouse gas emissions. So, the nitrous, especially nitrous oxide emissions from the rice field. So, as you know, the rice loves standing water, you can say we grow under waterlogged conditions sometimes, though the production wise rice does not require the standing water to have a higher productions, and because rice grows under standing water conditions, none of the other crops may fail to grow under the waterlogged conditions. So, under that when there is standing water, when you go for the fertilizer applications, especially the nitrogen fertilizers, where should you apply N fertilizers? If you apply in the surface water, so there is a less efficiency, because most of the fertilizers that is converted, that is lost as a soluble in water and the runoff loss. If you apply in the oxidized zones, that is the surface soils, so what will happen, the urea as a nitrogenous fertilizer, this is under hydrolysis converted to ammonium, and the oxidized layers as oxygen is present, that is oxidized to nitrate, and nitrate because of the concentration gradient that goes to the bottom layer, that the reduced layer. And in the reduced layers, as there is no oxygen and the nitrogen gets lost as a denitrification loss, as a nitrous gets reduced, the nitrate gets reduced to nitrous oxide in the reduced layers as there is no oxygen, and this N2O as nitrous oxide lost to the atmosphere as nitrous oxide emission. On the other hand, if you go on applying fertilizer at the reduced layers, the bottom layer you can say, where there is no oxygen, the fertilizer remain there, because urea under hydrolysis that is converted to ammonium, and as there is no oxygen, so ammonium may not be converted to nitrate. So, as ammonium is the form which that rice can take as a ammonium form for the nitrogen fertilizers, and you can have a better productions and you can have better efficiency. So, if you see the 3 layers, if you apply flood water, so that is the fertilizer is lost through runoff, and that contaminates your rivers, flows rivers, and that affect the fish population in the river and make the eutrophication of the surface water. If you apply in the oxidized zone, so there is a less efficiency, because the nitrate after the nitrification process, the nitrate as a concentration gradients or the leaching come to the reduced layer, and there is less efficiency, and that is lost to the atmosphere, as that causes global warming. And if you apply the reduced layers, so there is a efficiency is higher, that means the crop gets these nutrients and the production gets increased. So, that is what the example of the yield management. Improper application of the fertilizer can cause the global warming and can cause the greenhouse gas emissions from the agricultural field, and our management practices should be proper. We should change the management practices, we should know the scientific management practices to apply fertilizer and right type of fertilizer, so that we can minimize the emission of greenhouse gases and minimize the climate change. And if you see the indicators, that is policy, practice and performance. When you go for the performance evaluation of indicators, then there should be policy, government, this comes from the government level policy, and somebody should see and observe, and whether there is a policy comes in practice. Once there is a practice policy, then policy comes practice, and then there is a performance evaluations. So, if you take up indicator water, climate change, and we will go for the others. So, water, so the policy level you say whether there is the existence of policy requiring the measurement of agricultural water withdrawal. So, if you want the farmer should make efficient use of water and economic use of water as one of the indicator of sustainable agriculture. So, there should be policy. Once policy is in force, then farmers should be very cautious to withdraw groundwater. If there is only measurement, nothing to say, only there is a measurement how much water the farmer is withdrawing. If that system, that mechanism is there, then farmers will be very cautious and he can only withdraw the amount of water that is required for his productions. And the practice, at the same time we should know the share of the agricultural land that is under efficient water management practices. If that practice is if you know the percentage, how much percentage of agricultural land is under the efficient water management, that efficient means we are talking about the limited irrigations, as you drip irrigations, sprinklers or overt irrigations, or you can say as a not exactly flood irrigations, the region furrow, alternate furrow irrigations. So, those things, so the share of land area under the efficient water management practices in percentage, that has to be accounted. Then we can go for the performance evaluations. So, if we have the policy, then there is a practice of economic or the efficient use of water, then we can go for the performance evaluation of water use. That means, the water productivity or the water use efficiency and water stress ratio. Water productivity means the amount of drops per unit drop of water, per unit amount of water, that can be calculated, and also water stress ratio, water demand and water supply. So, you can compare region to regions, the performance evaluations can be done. Similarly, if you go for the climate change indicators, so the policy for the climate change, to know the where there is a greenhouse gas emission from the agricultural operations. So, whether there is existence of policies promoting low greenhouse gas emission from agricultural activities or agricultural development. If there is a policy, yes, then farmers should know then we should know the share of farmland or the farm area with agricultural greenhouse gas emission management percentage of land under greenhouse gas emission management. That means, the percent of land that is taken care to minimize greenhouse gas emission, as you know the activities they can be management practices that ensures less greenhouse gas emission, like minimum tillage or the stubble mulch tillage practice, or you can say the organic farming, organic nutrient management, say crop rotations with the legumes, less use of synthetic fertilizers. So, share of the agricultural land under greenhouse gas emission management and the water management. If you go for the flooding like rice, if you go for the flooded rice, there will be more emission of methanes, anaerobic decomposition of organic carbon compounds, that causes methane emissions. On the other hand, if you go for the saturations, there will be less or no methane emissions. So, if you know the there is a policy whether there is a greenhouse gas emissions management practices are followed, then farmers will be cautious, then you should know how much farm area that is under the greenhouse gas emissions management, and then you can calculate the performance evaluations, that is a food productions per unit greenhouse gas emissions. That means, the global warming potential of agricultural productions, amount of greenhouse gas emitted per ton of the agriculture per unit weight of the agricultural produce, tons of the food per ton of the CO2 equivalent, that is the global warming potential can be calculated. This is for the water climate change. Similarly, if you evaluate the policy practice and performance analysis for other indicators like land conversion and soil health. In land conversions, we can have the existence of policy limiting conversion of natural ecosystem to agriculture, yes or no. If so, then share of agricultural land enrolled in agricultural reserve program. Then we can have the performance evaluations like the conversion of natural ecosystems like the forest lands to agricultural land, and or you can have the share of agricultural land over the x years that was stable, and share that shifted to natural land, and share that grew from natural land conversions. So, this type of performance analysis that indicates to check the how we can check the conversions of the forest lands to agricultural lands, or the deforestation can come into can check the activities of deforestation. Then you see the other indicator, the soil health. So, as I discussing if there is a policy, existence of policy that promote agricultural soil conservation practice. If there is a so yes or no. So, the practice means the soil conservation practices. So, we have discussed the earlier classes, say contour planting, how you can do the contour planting, the growing the crops across the slopes, and the minimum tillage operations, and we have the broad bed and the furrow system of cultivations, so that the erosion, soil erosion can be checked. So, this type of the practice or the soil erosion or the stubble mulch tillage, how you can minimize the water and wind erosions, whether there is a policy, that is a existence of policy to promote the agricultural soil conservation practice. If so, then share of arable land under soil conservation practices, that should be in percentage. This is a, so first one is a qualitative measure, that is a yes or no. The second one is a percentage, is a quantitative, we can quantify how much area under the soil conservation practices. Any type of conservation we can say, either the management through agronomic management or as a engineering approach, agronomic approach or the biological approach, what the soil conservation practices are followed, so percentage of area under soil conservations. Then we can have a performance evaluations like the share of agricultural land affected by soil erosions, and also we can have the soil organic matter content. If there is a conservation practices over the years, then that helps in build up of soil organic carbon. If you compare the lands where the conservation practices are not followed and the land where the conservation agricultural practices are followed, so that we can evaluate change in soil organic carbon over the years. So, that give indications of the sustainability. And the other one can say the pollution. This indicator as a policy, practice and performance analysis for pollutions. So, policy for the nutrients, existence of policy promoting nutrient management practices, yes or no. So, as you discussed, so nutrient means what type of nutrients you are using, that is the type of fertilizers and the source of fertilizers, the application method. So, just discussed how the N fertilizer management. If you apply nitrogen fertilizer at the oxidized zone, that means surface layer, so that will give that will decrease the efficiency of N fertilizer for the crop use, and also that can cause the global warming, that cause the groundwater pollutions by leaching the nitrate to the groundwater, contamination of groundwater, nitrate contaminations, and also that can cause global warming through denitrification through reduction of the nitrate to nitrous oxides and release to the atmosphere. So, that is the existence of policy promoting the efficient nutrient management, whether the proper nutrient management, whether if nitrogen fertilizer is applied, whether applied as a proper depth, especially in case of rice, or we are using organic. So, in case of the if you are using the synthetic fertilizer, especially in case of the aerobic crops also. So, that is the so because ammonium or the nitrate fertilizer, so that gets converted to nitrous oxide too, through some soil. There are some denitrifying bacteria present in the soil, even though there is aerobic conditions. If you are applying synthetic fertilizer, that is a fast release of nutrient is converted to nitrate, and this nitrate is denitrified by the bacteria that are present in soil under aerobic conditions. If you are using the organic fertilizers, it is slow release, and as release is slow, then loss will be less. It is taken up by the crops, and there will be whatever loss is very low as compared to the chemical fertilizers. So, that is what the policy, if there is a policy promoting nutrient management, and the practice, then you can have the share of agricultural land under efficient nutrient management practices, the percentage. Then we evaluate the performance. Performance means the nutrient input balance on agricultural land, and fertilizer applied per unit of arable land. Input balance means how much fertilizers or nitrogen or phosphorus, how much nutrients applied to the crops. Then loss, the output, the crop removals, the loss may be to the groundwater contaminations, or loss to the atmospheres, the emissions to the greenhouse gases, or the amount remain in the soil, how much. So, that input balance per the nutrient input balance and the fertilizer applied per unit of arable land. So, that type of performance evaluations for the nutrients. If you go for pesticides, so the policy action to ban or restrict pesticide and toxic chemicals for use in agriculture. So, like there in India we have so there is a BSC, benzene hexachloride, DDT, dichloro-diphenyl trichloroethane. So, those pesticides are banned. We have the policy. So, so there is so that means the policy is there. So, there is action to ban the restrict the pesticides use. The practice, that means we have to say share of cropland under integrated pest management. That means the portion of land they use less and less pesticides. So, if you have the policy, the farmers become conscious and you have practice based on monitoring the amount of land under the less insecticides or minimum insecticide and pest management, then you can go for the performance evaluations, that is pesticide use per unit of the cropland, that is tons of active ingredients applied per hectare. So, these are the indicators. They if you go to indicators, then the policy, the policy from the government sides and the practice and the performance analysis can minimize and can make economic use of the resources, natural resources like the water or you can see soil health or the pollutions as you say fertilizer pollutions or the pesticide pollutions as you say. So, this can be controlled by the policy and looking at the practice and the performance evaluations. So, for this lecture as you say, so these are approaches to achieve sustainable agricultural productions. That means, so these indicators as you said the 5 major indicators, either you go for water or the climate change or the soil health or the pollutions either through nutrients or the pesticides and the land conversions. So, if you consider the 5 key indicators and if you go for the real evaluations, performance evaluations, then we will be able to achieve sustainability in agricultural productions. That means, so our practice should be done to maintain the food productions as per the need to meet the requirement high amount of productions. At the same time, we should see the less water, use of the less water, less energy and less inputs like fertilizers or in integrated way, so that we can achieve sustainability in agricultural productions, looking at the indicators and making the best use of the resources in integrated manner. Okay. Thank you all.